So we've covered types 1, 2, and 3 of finding domain. And just as a reminder, we saw quadratics in the denominator, and we basically factored those and then solved for x for when our denominator would be 0. And then type 2 is we had radicals, and we had to make sure those linear equations under that radical were greater than or equal to 0. And then my last problem on the last video was having both a radical and making sure the denominator was not equal to 0. So what we're going to do in this video is we're actually going to cover type 3 again, because that is challenging and I feel like we need a little more practice. And then I'll cover type 4, quadratics under a radical. In a different video, I will cover type 5. All right, so what do we know about radicals? Well, we know that the radical has to be greater than or equal to 0. So I have to set 2x minus 5 greater than or equal to 0. I'm going to add 5 to both sides. I get a 2x is greater than or equal to 5, or x is greater than or equal to 5/2, which is what, 2.5? What else do we have? Well, we also have that x is not equal to minus 7 from here. But the good news is that I know that x has to be bigger than 2.5, which means that we already have eliminated negative 7. So our final answer here is going to be from 5/2 to infinity, because we have to be bigger than this, which means that although this is true, it's not even in that interval right there. So a quick summary of how to solve these. Just make sure you set the thing under the radical, the expression, to be greater than or equal to 0. Okay, and then you also have to just make sure the denominator is not equal to 0. And sometimes that thing won't be in this interval right here, and sometimes it will be. All right, let's try another one. So we're going to set this right here greater than or equal to 0. Remember, when we divide by a negative, we have to flip the sign. So I have x has to be less than or equal to 4. And here, I cannot have 2x plus 6 be equal to 0. And you don't necessarily have to put that not equal sign, but no big deal. So divide by 2. So x cannot be equal to negative 3. Well, this actually is interesting here. We cannot have x be equal to negative 3, but x has to be less than or equal to 4. So if you look at our number line, here's my 4. I'm basically implying that I want everything to this side, okay, but I don't want negative 3. So I want this, and I don't want this. So our final answer is going to be from negative infinity to minus 3, union minus 3 to 4, and I'm going to include 4 in a hard bracket because of this equal symbol right here. All right, that's our answer there. Okay, now this is a brand new problem, type 4, quadratics under the radical. Well, think about what a quadratic looks like. So here's a typical quadratic with a positive 1. Would be something like this. And we actually want to have something greater than or equal to 0 under here. So the interval that will be allowed in the domain will actually be this section right here and this section right here. Well, how do you find what that value is? Well, you have to find the zeros of the function, or the roots, and to do that we have to factor it. So step 1 on these problems would be factor. So factoring this, I get, let's see, what adds to negative 3 but multiplies to negative 10. that would be an x minus 5 and x plus 2. So first step would be to factor under the square root. Step 2 would be to find the zeros / draw the picture. So here, what are the zeros? Well, in this case, we have an x equals 5. In this case, we have an x equals negative 2. So here's my 5, and here's my minus 2. So how can I write an interval for this section right here? Well, remember, that keeps going forever to the left, which would be from negative infinity to negative 2. And I actually want to keep the negative 2 because it's okay that my radical is 0. Then I'm going to say union, and now I want to do this, and that's going to be from 5, including 5, all the way off to infinity. So our final step right here, step 3, would be to circle the good stuff, which would be basically above, all the stuff above the x-axis where it's positive, because remember we want under the radical to be positive or equal to 0. And then you're going to write your interval. That's a v. All right, you can pause that if you want. Okay, here's another one. This one, unfortunately, is going to be that problem where we have to draw our telephone. So we're trying to multiply to 2 and add to negative 4. So what is that going to be? Well, it's pretty clear to me that there's no easy answer to this, so we cannot do it this method. We can, however, do it with the quadratic formula, or we can do it with graphing calculator. So remember, for the graphing calculator, you would graph it, you would find your zeros by going second calc, then clicking zeros. So why don't you just pause this video and see if you can find the zeros and then come back. All right, hopefully you're back. And I probably personally would have just done it on my graphing calculator. And I get a value right here of 0.293 for x. And then I get a value right here of 1.707. Okay. And again, I want the values that are greater than or equal to 0. So what I really want would be this and this, because it's greater than or equal to 0. We want something to be positive or 0 under the square root. So we're going to have from negative infinity, remember you always want to start from left and go right, so from negative infinity to a 0.293. I'm going to have closed brackets because I can have 0. Union 1.707 to infinity. And we can never be equal to infinity, hence why we have the open brackets. Sweet. All right, how about this one? Can we do this one with our method where we factor? Let's see. We're trying to multiply to negative 7, and we're trying to add to 5. That doesn't work either, right? Because oh, hold on. Yeah, I think it does work. How about a 6 and a minus 1? Yep, that works. So I'm going to have this right here break to, no, that doesn't multiply to negative 7. What am I thinking? Sounds like this one also is going to have to be quadratic formula or graphing calculator. So when I graph this, and you should do this along with me, please, I get, interesting, because this is negative, it's going to be a sad face, which is actually a really important problem. I'm glad we're doing this. Okay, you get something like this. And this value right here is a negative 0.163. Okay, and this point right here is a 0.877. And this is a little different because it's a sad face, and the part that we actually want to keep is just one interval. And that interval is going to be from a negative 0.163 to a 0.877. And we can have 0, and that's why I keep those values. All right, we are done with this particular type, and that's it for now. Make sure you do the video problems. Bye, y'all.